Hey, welcome back. And a while ago, we looked at the empirical rule, right? We looked at the 68%, 95%, and 99.7%. Is that okay? And we looked at a number of problems under the empirical rule. All right, nice. Now, this time we're going to look at something different. And wow. Well, I would say something really different, but we're going to be looking at z-scores. Now, to use z-scores, we look at z-scores and percentiles. And I would like you to get your yellow sheet, okay, pages 236. Get that handy. So your formula sheet, get that handy. There's a table on pages 236 that we are going to be using under z-scores, okay? So get that ready and let's start discussing z-scores. Okay, is that ready? Okay, sweet. Now let's go. Now we recall the total area under the normal curve is 100% or 1.0, right? Now due to symmetry, the area to the left and to the right of the mean are 100%. Now you remember the number line analogy I demonstrated to you before we looked at the empirical rule. Now the numbers right here, so basically these are what we refer to as the z-scores. So these guys are what we refer to as the z-score. So z-scores are basically negative and positive whole numbers, all right? But technically, a z-score actually goes between negative 3.5 and 3.5 and positive 3.5. Is that okay? So z-scores are just negative and positive whole numbers, basically, and they range between minus 3.5 and positive 3.5. Any number that goes beyond that, we consider that statistically, in statistics, we call that an outlier, okay? And we will look at the height of some three people, Yao Ming, Kevin Hart, and one other person, and we realize that Yao Ming is an outlier, right? You rarely get people in that category, that kind of height. So let's see how z-scores work. And here we're going to be dealing with the formula. And that formula is also on pages 236. Okay, we call it z-score formula, right? So z-score is that. So z is equal to value minus the mean and the standard deviation. So at any point, three of these values will be given, right? Will be given to you and you'll be asked to find the other. Nice. So you recall the manufacturing example with an average of 1040 and a standard deviation of 25. Okay, we want to find the z-score for a bag that weighs 1,000. Okay, so we just plug in. So 1,000 becomes our x, and we know that is our mean, and then our standard deviation, and that gives us minus 1.6. Okay, test that. Check that and see if you get that. And that is what we call the z-score. Is that okay? Nice. Now, so that is the formula. So now let's look at an example. The average adult is approximately 70 inches in height. And we will use a standard deviation of sigma being equal to 5 inches. Now we want to find the z-score for a man who is 65 inches in height, and we have to use the z-score formula. Okay, so our x will be 65. We take away 70, which is our mean, and then we divide by our standard deviation, and that will give us what? Minus 0.1.0. Okay, or minus 1. Now, what is the z-score for a man 77 inches in height? We plug that into the formula. So this time our x is 77, and that gives us positive 1.4. Isn't this easy? So this is so simple, right? Now be careful when you're doing, if you want to plug all the numbers in your calc, make sure you introduce parentheses. Because if you do 77 minus 50 minus 70 minus 70, and then you just do over 5, it will just divide, you get a different answer. 70 divided by 5, okay, will just give you what? So you are going to get something different. So 70 divided by 5 will give you 14, and minus 77 will give you minus 63, which is not true. This is not correct. So if you have to put everything in your calc, make sure you are doing 77. So introduce parentheses, minus 70, parentheses, and then you divide by 5. That way everything divides by 5 and you get that. Okay, that's just by way of caution. Now, and find a z-score for a man who is 6 foot 2 inches tall. Okay, you have to change this into inches, right? You have to harmonize. So 6 by 12, okay, and then plus 2. So 6 by 12, because why do you do that? We did the convergence, right? 1 foot is 12 inches. So 6 times 12, okay, plus 2 gives you what? 74. And you have your z-score to be what? 0.8. Now, how tall is an adult male who is 3 standard deviations above the mean? So this time we've been given the standard deviation, right? So we have our z given to us, and we want to find the height. So our z has been given, and we want to find what? X. So we know that was given, right? So this is 70, and then we have what? 5. Is that okay? So this gives us 15. We cross product from there. 15 is equal to x minus 70. So x will be equal to what? 15 plus 70, which is what? 85 inches. So that is how you find that. So when either three terms are given, you should be able to find the other. All right, so we have these 3 gentlemen, right? Do they look familiar? Okay, so what is the z-score for Yao Ming, a basketball player from China who is 7 foot 6 inches tall? Where is this on this graphic above? Okay, so if you do that, you have to change this into inches, right? So you multiply 7 by 12 plus 6, and that gives you 90. And Yao Ming's z-score is 4.0. That is off to the right, right? So Yao Ming is an outlier, okay? It's an outlier. You rarely find people of that height, okay? Now, in the previous section, we learned about the area under the curve for 1, 2, and 3 standard deviations from the mean. We can use these scores in the table below for values that do not fall directly on a standard deviation. Okay, now the table in the book gives the proportion under the normal curve to the left of the given z-score. And note that the table gives proportion under the normal to the left of the given z-score. Now, what is the z-score for a man who is 63 inches? And you do that, and that gives you what? Minus 1.4. So if you have the table, we are looking at the table on pages 236. Pages 236. And there's the table we are talking about. There's a table. Can you see that? Okay. So you realize that this table has z-scores and they have the corresponding probabilities. Is that okay? So if you go by, so we are looking at using z-scores to find probabilities. So if you find a z-score, you go to the table and look for the corresponding probability on the z-score table. Is that okay? So basically that is what we did. So when we had minus 1.4, we went to the table, you go to the table and look for minus 1.4. So this is minus 1.4, right? And the corresponding probability of minus 1.4 is that. So that is a value, and we changed that to a percent, and that gave us 8.08%. Is that okay? Nice. Now, we wanted a proportion of men that is taller. We have said that the table gives us to the left of the curve. So this is left of the curve. So if you want the proportion that is taller, we have to take away this number from 1, because the whole area under this is what? 100%. Okay. So you either use the decimal. When you use the decimal, you use 1. You subtract from 1. And when you want to use a percent, you subtract from what? 100%. Okay, good. So note, this is a table we are using so far. Is that okay? Now, work out this problem for actor Danny DeVito. Okay, look at it. So right here, we have the mean, okay, and we have the standard deviation. Actor Danny DeVito is 5 foot. Now we have to change from feet into what? Inches. And that gives us 60 inches. So 60 minus that. Now we have to go back to the table. So go to the table. Okay. Now we want what proportion of men is shorter. So we go to the table, and let me go back to the table. So what did we get? We had minus 2, right? So minus 2, this is it. So, and that will be our answer. We do not subtract because we want shorter. If it said taller, we were going to take away this. We would do minus 0.0228. If it said taller, right? Or we do 100 minus 2 point, let me write this word, minus 2.28. Okay, if it said taller, but because it says shorter, we just want that. Okay, nice. So that is how this works. So note, read this instruction closely. Now, using the value, your value from part B, determine how many men out of 100,000 would you expect to be as short as actor Danny DeVito. So now you take that proportion and multiply by the number, and that gives you the number of people that are within Danny DeVito's height, right? Now, what is the probability a man is taller, right? So now a man is taller, and I already showed you how to do that. So you subtract when it is a man is taller. Nice. Okay, so here we do more z-scores. So we find a z-score for a woman in the United States with 64 inches. Okay, and then we go to the table. What's the probability that a man is shorter than the average woman? Okay, so you go to the table with minus 1.2, and you find that this is the value on the table. Now, what proportion is taller? Taller, you have to take away from 1 when you use a decimal, and from 100 when you use a percentage, and you get the same answer. Okay, nice. Now, we do more examples. So a particular brand of tires lasts an average of 40,000 miles with a standard deviation of 3,000. What is the probability a tire selected at random lasts more than 42,000 miles. Okay, and now here, when you go to the table, you realize that you wouldn't find 0.67. So you round up. The nearest, the closest number on the table is that. Okay, and because you want last more than that, that is what you have, and you take that away from 1, and that gives you that. So anytime you check value on a table and you don't get the exact value of your z-score on the table, you look for the closest, and the closest to that is 0.65. Okay, nice. Now we have that. So be mindful, we are dealing with kilograms, right? What probability? The probability selected at random, a baby weighs more than 10 pounds. So you have to change from pounds to kilograms. Okay, and you find your z-score. Now from the table, that is what the value gives you. And a baby weighs more than that, you have to take that out of 100%, and that gives you the result. So basically here, you're just dealing with the formula A. Z is equal to that over that over that. Now the value, whatever value you have, you pick that number, and then you go to the table on pages 236 and look for the probability that goes with the value of your z-score. Okay, and you look at it, whether if the problem says more, you take away from 100%. Okay, if it says less, you maintain the value that you found on the table. And we are looking at another example here, and similar stuff from the table. So if you look out minus 1.5 on your z-score table, that gives you that. Is that okay? And basically, that is all we have to do under this section. Isn't this interesting? Pretty simple, right? Yeah. Okay. So that is basically all we have to do under z-scores. So under z-scores, we are just using the formula z is equal to x minus the mean over the standard deviation. Now we're going to be talking about percentiles. Okay. Now percentiles, really we are just dealing with median. That's all we're going to talk about under percentiles, median. Now, if you remember, we looked at how we can find the mean, the median, the range, and all that. Now, when we talk about percentiles, we are just going to focus on the median. Now, you know that for median, order is important, right? So whenever you have a data set and you have to find the median, you have to first of all order the data set either in ascending order or descending order. And then the number that sits right at the center becomes your 50th percentile or your median. So the median is the 50th percentile. Now, when you have found the number that sits right at the center, you look at the other half of the data set. And then you also look for of the numbers to your left, what sits at the center to your left, and then you look at to your right, what number sits at the center, and you have your 25th and your 75th percentile. So basically that is all we are doing under percentiles. So first order your data set. The 50th percentile is the number that sits right at the center. Now when you have found the 50th, break the 50th, that breaks the data set into two. Find the median for the left half, and then find the median for the right half, and you have your 75th and your 25th percentile. Okay, so basically that's all we are going to be doing. So what z-score corresponds with the median of the data set? Explain. Okay, so 0, right? So if you go to the table and look for 0, the corresponding z-score for 0 is 0.5, which is 50%. Okay, that is what we call the 50th percentile. So basically what we are saying is that the table you see on pages 236, these probability values are also referred to as percentiles. Is that okay? Percentiles, and we will see some examples in a bit. So here you recall the Mensa family, right? The IQ 100. So, and that an IQ of 120 falls within the 98th percentile. Okay, and the 99th percentile. So because this Z-score value, if you look at the table, that gives you that. Now this is approximately 99%, and this is what 99th percentile. Is that okay? Nice. Okay, nice. So here, if we look at Danielle and 59%, 59 on the standardized test for spelling, the national average is 60. If you look at this Z-score, okay, on the table, so if you go to the Z-score table, minus 0.10. Do you see that on the table? Minus 0.10. Okay. If you see that on the table, and that should give you the value you have there, and that value is referred to as the same as the 46th percentile. Sounds good? Gucci minus 0.1. Okay. So that is basically how you deal with percentiles. Okay. Now we look at how you can find same percentiles, or referred to as quartiles, when you have a set of data, right? So here, if we had that 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is an odd number, right? So when you have an odd data set, what happens is that you always have a number that sits at the center after your data has been ordered. And that is your 50th percentile. Now you look at the remaining half to your left, 1, 2, 3, 4. Now you don't have a single number that sits at the center to your left. So you have to put this and that together and divide by 2, and that gives you your 25th percentile. And then these two numbers sits at the center to the right. Okay, so you put these together, divide by 2, and that gives you your 75th percentile right there. So there's a way to deal with odd data set and an even data set, and we look at. So this is an odd data set. So for an odd data set, you have a single number sitting at the center, and I'll highlight more on an even data set, and again on an odd data set soon. Okay, so that is nice. So we already did that. Now example number 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. Okay, so 10 data points, and this is an even data set. 10 is an even number. Okay, so for an even number, you wouldn't have a single number sitting at the center, but you have 2 numbers. So you have to put these 2 numbers together and divide by 2, and 40 becomes your 50th percentile. Okay, so 40 is now your 50th percentile. Now you do 1, 2, 3, 4, 5. Okay, you have 1, 2, 3, 4, 5 numbers, and this sits at the center of the 5 numbers to your left. So this is your 25th percentile. And 1, 2, 3, 4, 5. 58 sits at the center of the set of numbers to your right. Okay, so 58 becomes the 75th percentile. Okay, isn't this simple? Pretty simple, right? Okay, good. So right there, you have this data set, and check. The first check you need to do is that make sure the data set is ordered, right? And you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is an odd data set, 11 data points. So this is odd. So you have a single number sitting at the center. So the 50th percentile is that. Now you do 1, 2, 3, 4, 5. Okay. And what happens? You have this number sitting at the center, so that becomes your 25th percentile, and you have 1, 2, 3, 4, 5, 66 is at the center, and that gives you that. Okay, sweet. Now, so order the data set first. Okay, and note 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12 data points, which is even, right? So two numbers are going to sit at the center. Okay, so we are going to add them and divide by 2, and that will give us our 50th. Okay, now we do 1, 2, 3, 4, 5, 6. Now these two numbers will sit at the center to the left. We'll add them together and divide by 2, and we have your 25th. And then we do the same thing towards our right, and we have our 75th percentile. Okay, so sweet. All right, now here let's explore and let's do some critical thinking right here. So Uncle Bob says he is taller than 80% of all men. So here we are given the probability, right? And we have to, so we have been given, basically we have been given the probability, and we can use the probability to find the z-score. So 80th percentile, we go to the z-score table, and that is 0.85. So you have to go to the z-score table and look for 80th percentile. Okay, 80th percentile, okay, gives you a z-score of what? 0.85. Now you want to find x, and that gives you that. Now, what proportion of men would we expect to be between this height? Okay, and that is how you do that. So you find the z-score for both, and that gives you minus 0.4 and 1.2 z-scores. Okay, nice. All right, so we do similar applications here with this example, okay, and work these out, and that's all. So we are dealing with the z is equal to x minus the mean over the standard deviation, okay, and this is an application diagram, and we know that this is what this is typically right skewed, okay, and you use the same kind of formulas to right, the z-score formula to find the z and the corresponding probability from the z-score table. All right, and here the class intervals for these. All right, so take your time and work through this practice and check if you get the same answers I have produced for you. Okay, so nice. So z-score is pretty simple. You just deal with the formula. Okay, so the values you have on the graph or yeah, on the table actually give you less. So if you have to find more, you just take away from 100 if you are dealing with percentages, and you take away from 1 if you are dealing with decimal numbers. Okay, so it's just a one-way thing that you do. So z is equal to x minus the mean over the standard deviation, and you use that to find your probability values. And don't forget that these probability values are also percentiles. Okay, so don't get confused when you're asked to find percentiles. So when you know the z-score, the corresponding probabilities are also percentile values, and you can use those to find your results. Is that okay? All right, so almost through, and thanks so much for your time. Okay, until I come your way with section number 16. And under section number 16, we are going to be discussing probabilities, right? And then finally, we look at the last section that we need to look at for section 17, where we talk about margin of error. All right, so margin of error, and that'll be it for the semester. So thank you very much for your time, and See you soon. Bye-bye.